All right, you guys, so we're going to be going over what is density. We've covered mass, we've covered volume. When we go into density, we call this our density triangle. One, because it is a triangle, but two, it also gives you your formulas on how to rearrange the equation. Density is equal to mass divided by volume. So when you're using your density triangle, you will take whatever you have. In this case, I made a circle, and you're going to cover it over what you're looking for. So if you're looking for density, it's mass divided by volume. If the question is asking for what is mass, it would be density times volume. And if you're looking for volume, it would be mass divided by density. So this density triangle, before I get into anything, is a really useful tool that you can use on problems. I always recommend, if you are solving for things, to write it down, and that way you can cover up whatever the question is looking for. But for today, we're going to focus on density and just solving for density. And density is equal to mass divided by volume. So there's two types of densities. We have density with regular and we have density with irregular. So we're going to focus on regular first. So we've already covered that mass is the amount of matter that an object contains, and the mass of an object is taken by using a triple beam balance. For example, let's assume that the mass of a cube A is 2.5 grams. So we're going to come back to this, 2.5 grams. And for regularly shaped objects, like the cube, a ruler is used to measure the length and the width and the height. And you have to multiply those three numbers together in order to get the volume of a regular shaped item. So you would take a ruler and you would measure the length, you would measure the width, and you would measure the height. And it's going to give you your units in centimeters cubed. Now, where do you get that cubed from? Well, if you're looking at your problem, you're going to be multiplying three different numbers that are centimeters. So that's 3 centimeters, and that's where you get your centimeters cubed. So if we have a length of 1, so we have 1 centimeter, and we have a width of 0.5, and we have a height of 1 centimeter, you're going to multiply 1 times 0.5 times 1, which gets you 0.5 centimeters, I'm going to do a little caret, cubed. So that would be your volume of this cube. Now remember, we said the mass was 2.5 grams, and our volume of a cube was 0.5 centimeters cubed. So density is equal to mass divided by volume. So all you have to do is put those numbers into the correct place. 2.5 divided by our volume, which is 0.5 centimeters cubed. And then you're just going to plug that into your calculator and you're going to get your answer. So 2.5 divided by 0.5 gets you 5. And we divided grams. So let me come back and put my unit. We divided our gram by our centimeters cubed. And so when you're doing your units for density, since you divided grams by your centimeters cubed, that's how you would write your units, centimeters cubed. Now, what happens if it's an irregular shape? What if you can't take a ruler and measure it? When an object is irregularly shaped and the length, width, and height cannot be measured with a ruler, then the water displacement method is used to calculate the volume. So we practiced this earlier. It's where you take the initial volume and you take the final volume after you put the object in and you subtract them. So a graduated cylinder is used to measure a given volume of water. The object is then added to the cylinder. So we took the dinosaur, we put him into the graduated cylinder, and the water level rose. So the initial volume is subtracted from the new volume to give you what the actual object is for volume. So you gotta subtract. So in this case, we filled it with 4.8 milliliters of water, and the dinosaurs added, raising that up all the way to 5.6 milliliters. So if you take the final volume and you subtract it from the initial volume, you will get 0.8. So you're just subtracting the two. So the mass of an element sample was calculated to be 18 grams. So there's our mass. A graduated cylinder was filled to the 70 milliliter mark, and then the rock was placed in the cylinder. So using the information below to determine the volume, density, and identity of the unknown elements. We're going to be solving this one on the next slide. So our mass was 18 grams. Our initial volume was 70. So what is our final volume? What did that go up to? So let's count. So that's 70. So 71, 72, 73, 74, 75, 76. So it's 76 is our final. Now we have to subtract it. So 76, and we subtract our 70. So our volume of the mineral is going to be 6 milliliters. So our mass, we got to go back and find our mass again. So our mass was 18 grams. There we go, 18 grams. That's not a G. There we go. And our density was 6. Our volume was 6. So mass divided by volume. So you're going to put it into your calculator. 18 divided by 6 gets you 3. So our volume, our density, is going to be 3 grams per milliliter. Where do we get the grams? Right here. Where do we get the milliliters? Right here. And what mineral is it? So now we have to look at our list at which one is 3 grams per milliliters, and it's aluminum. So that unknown mineral, aluminum, yes. I'm a terrible speller. So that is how you will solve density for irregular shapes. You got to do your water displacement first, and then you can go through the problem of solving mass divided by volume.